This is section 16 from our course. Make our line a little thicker here. And we're going to start off with the prep skills as always. And our first prep skill is to locate numbers on a number line. When it says here, when numbers live exactly at one of the labels on a number line, it's easy to decide where to put them. So, if we want to locate negative 15, here's 0. It goes by 5, so this would be negative 5, negative 10, and negative 15 would be right here. But if you have numbers that do not live at one of the labels, and we don't even necessarily mean at a whole number, depending on how the number line is labeled, it doesn't have to be labeled by 1. So for instance, this number line is labeled by 2s. So any number that's an even number is going to be easy to mark, but if you have anything that's in between those, they're not going to be right on one of the marks. So for instance, 3 would be halfway between 2 and 4. 8 would be, I'm sorry, it's not just 8, it's 8.2. So 8 is here, 10 is here, 9 would be halfway in between, and so we're past 8, but not to 9, so we're here. In fact, that one's probably a little bit high, because this is 9. Looks more like it's about 8.5. It should probably even be a little bit more to the left. Then we have 13.4, which would be past 13, almost halfway to 14. Then we have 19.9, which would be almost to 20, but not quite. Again, this is 18, this is 20. 19 would be right here in the middle, and so 19.9 would be very, very close to 20 in this case. So our next skill is kind of funny. They say that our next skill is reading bar graphs, pie charts, and scatter plots, and it says these skills have been previously covered. Cool. Bar graphs and pie charts are in lesson 1.1 and scatter plots are in 1.5, so they don't actually have any examples for that. So now we're going to go into the prep skills questions. So we're going to locate negative 40, negative 15, 15, and 27 and negative 2 on the number line. So we have to look and see what is it labeled by. Well, it's labeled by tens, and so negative 40 would be pretty easy to find because it's right at a one of the markings on the number line. 15, we want to be on the positive side now. Here's 10, here's 20. 15 would be halfway in between. So there's 15. Here's negative 40. Negative 15 would be the same, but on the other side. So here's negative 10, negative 20, negative 15 would be halfway in between. 27, here's 20. 25 would be right in the middle, so it's a little bit past 25. So past halfway between 20 and 30. So that would be 27. Negative 2 would just be, this would be negative 5 would be halfway in between, so negative 2 would be not even halfway to halfway. So right about there. So our next question says we have a pie chart here, and the pie chart shows the distribution of grades on a final exam. I just finished grading for Calc 2 class with 31 students. Okay. Completely made up. Use it to answer each question. What percentage of students got a B on the final? Well, it's important that we know that there's 31 students because we can't find a percentage of something if we don't know what that something is. So we know we have 31 students, and out of those 31 students, we know that 32% got a B. So we want to know what 32% of 31 is. So 32% is 0.32. Of means times typically in math. So 0.32 times 31 gets us, sorry I didn't do this ahead of time, 0.32 times 31 is 9.92. Now we're talking about students, so since this is 9.92, it's probably 10 students. Can't have a part of a student getting a B. So that probably, if it's 9.92, that 15 or 32% was probably rounded, and that's most likely 10 students. How many students got a C? Well, that's 7%. So 0.07 times, again, it's 31 students. So 0.07 times 31, I get 2.17. So again, rounding, that would be likely to be 2 students. How many students got a D or better? So that's not just asking a D, it's a D or better. I'm just noticing here that on part A it says what percentage of students got a B. So for that one we were actually done when we said 32% because it asked what percentage. This one asks how many, so this one we did have to do the 2 students. But on this one technically the answer was 32%. So on this one it says how many students got a D or better. Well, we had 26 that got a D, 7 that got a C, 32 that got a B, and 34%, or I'm sorry, 16% that got an A. So if we add those up, we have 26 plus 7 plus 32 plus 16. That's the percent that we're going to have. And so that's 26 plus 7, 32 plus 16 gets us 81%. The other way we could have done that is we could have gone up here and said, well, if you didn't get a D or better, that means you got an F. So we could have taken 19% from 100% to get that 81% also. But either way, we have 81% of the students, and there's 31 students still. So 0.81 times 31 comes out to be 25.11, so it would be 25 students. So 25 students out of the 31 got a D or better. That means that 6 must have failed. So now we're looking at a bar graph, and in this bar graph we have the number of students getting full credit on a question, on a 5-question quiz. So, or the first 5 questions on a final is what it says, not 5-question quiz. It's first 5 questions on the final. So question 1, 2, 3, 4, and 5. Which question was answered correctly by the most students? Well, of course, when we want to know most students, we're looking for the top, highest bar. So the question that was answered by correctly by the most students was question 4. So Q4. It looks like there were 25 students, but they didn't ask us that. They just asked which question. How many people answered question 2 correctly? Well, we can see it's more than 20, less than 25. So then it's a determination of, is it past half or not? It looks to me like it's past half. Half would be 22 and a half, so I'm thinking this is 23. 24 I think would be a little bit closer to 25. So I think it's 23 students. What percentage of the 31 students taking the test got question 5 completely right? Well, if we want to know the percentage, we have to know how many there were that got it right. So this one looks like it's a little below half to me. So again, this would represent 10 to 15, so 12 and a half would be right in the middle, which isn't actually a possible value. This looks like it's a little bit less than half, so I think this is 12 that got it right out of the 31. And so if I want to know what percentage got it right, I need to figure out what 12 out of 31 is as a decimal, which is approximately 0.387. So 38.7% of the students got question 5 completely right. So now we're looking at a scatter plot of these same grades, and it says first how many students scored less than 80 points. So let's look at this a little bit. This is the student scores on the Calc 2 final. The points would be here, and then let's see, it says on the horizontal axis is the student's position alphabetically on the class roster. So this is just whether they're student 1, 2, 3. So this is student 1, student 2, student 3, student 4, student 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is just the number that they are on the student roster. On the side is the points that they got on the test. So it appears that the maximum number of points that you could have gotten is 180. We're not 100. No, actually it does say here. It says out of 160. So 180 wasn't actually necessary. 160, but there must have been a chance for extra credit because there is a student that is above 160. So anyway, how many students scored less than 80 points? So we're going to look at how many students are below this line, because anybody above that line scored better than 80. So how many students scored less than 80 points? Looks like there's 1, 2, 3 students that scored below 80 points. How many students scored 140 or more points? Let's use a different color here. Let's use orange. Oh, let's not use orange. That's too close to the color that they used. Let's use a purple here. So how many students scored 140 or more? Now on this one, before it said less than, here it said or more. That many or more. So they could actually score 140 and be counted in this group. So we have one here that's 1. They actually scored 140, it looks like. 1, 2, 3, 4, 5. And then we go over here, 6, 7. That 7th person looks like they were right on again. And then 8, 9. Those people look like they scored right past 140, maybe 144 or 141 or 142. So I believe I said 9. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Students scored 140 or more. So they could score 140, 141, 142, 143, etc. About what was the lowest score on the test. So they're acknowledging here that we may not be able to tell exact, but we should be able to approximate. And the person with the lowest score is the one that's the one that's lowest on the graph, and they look like they scored somewhere. I mean, 50 would be here. They're below 50, 44 maybe. It doesn't look like it's quite halfway to 50. So I'm going to say about 44. So I got 44 out of 160. If you were to divide that just out of curiosity, a 44 out of 160 would be only a 28%. So now we'll be picking up with the class portion for Section 16 or Lesson 2.5 in the book that we're borrowing it from.
In question 1, you're asked to write a brief description of 2 or 3 problems that you've had to solve outside of school. Obviously, this is a personal question, so I don't have a sample response, but you should take a minute to think about it. In number 2, what are some methods that you use to solve problems in your life, and do you think that they apply to solving problems in college classes? This is again a personal question, so you need to think about some of the methods that you've used in your own life. However, some methods that might apply in both your own life and college classes would be things like thinking about key issues in the situation and considering possible solutions, choosing one of those solutions and carrying it out, and then reflecting back on how well it worked. One of the problem-solving skills that we work on is estimation. So we're given this timeline of important advances in medical science. Question 3 wants you to estimate the year that the microscope was invented and describe how you came up with that estimate. So the microscope was invented right here. And looking at that, it's pretty close to the year 1600. I need a better estimate than that though. So I'm looking at this and I've got 1500 and then a blank line and then 1600. So that blank line is 1550. And that helps me zero in on this a little bit more. It's definitely more than halfway between 1550 and 1600. So it's past 1575, very close to 1600. I'm going to call that about 1590. In number 4, we're supposed to estimate the year germs were identified as the cause of disease. So that's right here. And so looking at that, it's past the halfway point between 1800 and 1900. So that would be 1850 there. It's past 1850, but it's not quite halfway between 1850 and 1900, which would be 1875. So it looks like it's probably about 1860. In number 5, which happened first? The first test tube baby or the first heart transplant? So looking at these, here's the first heart transplant and here's the first test tube baby just to the right of it, which means the first heart transplant happened first, and then we need to estimate the years for each of those. And looking at this, both of those are between 1950 and 2000. The first test tube baby is almost right at 1975, halfway between 1950 and 2000. And the first heart transplant is a little bit before that, maybe 1970 or 1965. And in number 6, which happened first, organs grown from stem cells or the identification of HIV? Well, it looks like HIV identified comes first when you're moving left to right, and then organs grown from stem cells is just a little bit to the right of that. And then the years, HIV is a little bit before 2000, and remember that test tube baby was about 1975. It's just a little bit past that, maybe 1980, 1985. And then organs grown from stem cells is just a little bit past 2000, so maybe 2010. We're still looking at the timeline, and in number 7 it asks us to go back to question 5 and write an inequality using those years. Number 5 is where we decided that the heart transplant happened before the first test tube baby. So 1965 happens before 1975, which means 1965 is less than 1975. Now number 8 would like us to do the same thing with question 6, except this time we're going to use a greater than. Question 6 was where we decided that HIV was identified before organs were grown from stem cells, which means that the year organs were grown from stem cells is greater than the year HIV was identified. So 2010 is greater than 1985. In number 9, the two most recent events are organs grown from stem cells and skin cells used to grow stem cells. How do those dates compare? Well, they look almost the same on this timeline. It's very hard to tell whether there's a gap there or not. So then number 10 says, based on the order in which those labels appear, you would expect that organs were grown from stem cells before skin cells were used to grow stem cells. However, because they look almost the same, we should use a less than or equal symbol to represent that. So verbally, we would say that the year organs were grown from stem cells is less than or equal to the year skin cells were used to grow stem cells. So then if we assign a variable to each of those years, we could say O is the year that organs were grown from stem cells, and S is the year that skin cells were used to grow stem cells. Then in symbols, we could say O less than or equal to S. For these questions, we're making estimates using this bar graph of the monthly costs of homeowners insurance in different states. 11 wants us to estimate the monthly cost in California. Well, for California, that bar is just a teeny bit over 80, so we could probably go ahead and say that it's about $80. And then in 12, do you think your estimate's too high or too low? Well, that bar looks like it's just a little bit above $80, so our estimate is probably just a little bit too low. So in 13, we're going to use those two answers to write an inequality that describes the cost of homeowners insurance in California, with C representing the cost. So we decided that our estimate was probably just a little bit too low, and the actual cost is probably just a little bit above $80. So we would say that the cost is greater than or equal to $80. In 14, suppose you were planning a move to Arizona and you wanted to budget a monthly amount for homeowners insurance. Would you prefer an overestimate or an underestimate? Well, if you're trying to make a budget, then you probably want to overestimate so that if you're wrong, you have money left over, as opposed to underestimating and not having enough. So with that in mind, in number 15, what would you estimate for the monthly cost of homeowners insurance in Arizona? Well, the bar for Arizona is just a little bit below the $60 line, but we just got done saying it's better to overestimate than to underestimate, so let's just go ahead and call that about $60. Here we're making estimates off of this scatter plot of federal minimum wages in the U.S. So in 16, we're supposed to estimate the minimum wage in 2009. Well, the first thing we have to do is figure out which of these dots probably represents 2009, and that's probably this very last one here. That's really close to 2010. And then estimating that value, we would look at the fact that it's between $7 and $8, but if I kind of estimate what halfway would be, that would be about $7.50. So it's less than $7.50, maybe about $7.25. In 17, we want to think about whether our estimate is too high or too low. Well, looking at that, I marked off about $7.50 and I called that 7.25, but it's actually a little bit more than halfway between $7 and $7.50. So it's actually probably a little bit more than $7.25. My estimate was probably a little bit too low. In number 18, let's say we have a high school graduate trying to figure out how much to budget for college while working a minimum wage job. Would she prefer an underestimate of the minimum wage or an overestimate? Well, it's probably better to underestimate what you're going to make so that you budget for less and don't risk running out of money. In these questions, we're going to practice translating statements into mathematical inequalities. And then for each, we'll give an example of a value that would satisfy that inequality. So in 19, we can fit at most 12 people on the slow ride pedal bus. Well, first of all, our variable. Let's let n stand for the number of people we can fit. So then we can fit at most 12 people. That means the number of people we can fit is at most 12, or n less than or equal to 12. And so an example of a number that would work then would be something like 10. In number 20, it's estimated that there are at least 50 ways to leave your lover. So we will let L stand for the number of ways to leave your lover. And at least is greater than or equal. So in our case, L is greater than or equal to 50. An example that would work then would be something like 60. In 21, I get a text alert from my bank if the balance in my checking account drops below $100. So let's let B be the balance in my checking account. And so they would notify me when B is less than 100. A sample value of a balance below 100 would be something like $75. In 22, any amendment to the U.S. Constitution will only be enacted if more than 37 states vote to accept it. So let's let S be the number of states that vote to accept an amendment. And so that amendment would only be enacted if S is greater than 37. For example, if the value were 40. Here we're using isotherms, which are curves on the map that talk about temperature. And so in number 1, it wants us to estimate the temperature in Las Vegas, Nevada. So that's L, that's over here, And that is on, if you follow this line, the 40-degree line. So it's 40 degrees in Las Vegas, Nevada. In number 2, we're supposed to estimate the temperature in Phoenix, Arizona, which is P over here. Well, that one's not right on an isotherm, so we need to estimate what it would be. It's between the 40 and the 50 lines, and then to make our estimate more accurate, we need to think about, well, it is closer to the 50 than it is to the 40, so it's definitely past 45, maybe about 47 or 48 degrees. In number 3, we're looking at Dallas, Texas, which is D. That one looks almost exactly halfway between the 20 and 30 degree lines, so we'll call that 25 degrees. In number 4, we're looking at Springfield, Illinois, which is S, and that is very close to where I am right now. And that looks like it's between 0 and 10 degrees, much closer to the 10-degree line, so maybe about 8 degrees. And we're actually having a cold snap, and that is about what it was today. In 5, we're looking at Atlanta, Georgia, which is A over here. That's between 30 and 40, but much closer to 30, so we'll call that maybe 32 degrees. Number 6 is Miami, Florida, which is M down here. And that one we have to be a little careful with. We can tell that it's more than 50 degrees, but we don't have another line to estimate it with. So we're just going to have to do our best and say maybe that's about 52 degrees. And then for 7, we're doing New York, New York. So that is N up here. That's between 0 and negative 10. So the temperature is negative here. It's much closer to 0 than it is to negative 10. So we'll say about negative 1. In 8, we're supposed to estimate the monthly payment if we borrow $10,000 at 7% interest for 3 years. So just as an estimate, we can start off by calculating how much interest would accumulate if we didn't make any payments at all for 3 years. So we know using compound interest that that would be $10,000 times 1 plus 7%, so 1 plus 0.07 to the third for 3 years. And that comes out to $12,250.43. And that would be the grand total that we would have to pay back if we didn't make any payments at all until the end of the 3 years. Now with an actual loan, you're making payments along the way, so you'll owe a little bit less than that. And then if we want to divide that up over 36 months, because 3 years equals 36 months, then we could take $12,250.43 and divide it by 36 months, and that would give us a payment of just about $340. Now the next question is, if we were planning a budget, would we want to overestimate or underestimate? Well, we would definitely want to overestimate because we would want to make sure that we budgeted enough and didn't run out of money. In 9, an average cup of coffee has about 80 milligrams of caffeine. So how long do you think it would take for that caffeine to leave your system? We aren't really given any information to make an educated guess on this, so I would think when I have a cup of coffee after dinner, it can still affect my sleep, so it's obviously still in my system. So maybe it takes about 6 hours to leave my system. So then based on that, how many milligrams do you think will be in your system in half that time? Well, you would probably guess then that after 3 hours it would have dropped to 40 milligrams. But I'm making an assumption there that the caffeine leaves my system at a steady rate. In number 10, about how much would you spend in a year if you bought two $2.80 cups of coffee every weekday? Well, we can calculate this one pretty closely. So two $2.80 cups of coffee means that I'm spending $5.60 per day. And then I'm doing that 5 days a week. So 5 times $5.60 is $28 a week. And then we can estimate that there are about 52 weeks in a year. So 52 times $28 gives me a grand total of about $1,456. Does this surprise you? I knew it would probably be a lot, but it actually does surprise me that it's almost $1,500, and that doesn't really sound worth the expense. In these questions, we're going to estimate a value and then also think about what are the pieces of information that you would need to make a reasonable estimate. So in 11, if you put $1,000 into an IRA right now, how much would it be worth when you retire? Well, some of the things that we need to know to make a better estimate would be the average rate of growth on IRAs over time, and how many years it will be until you think you are going to retire. So in order to make our estimate, let's say that we earn about 7% on average and that we have about 50 years until retirement. Well, this would be another compound interest problem. So we would say that we have $1,000 right now, and we're going to multiply that by 1 plus our growth rate, 0.07, to the number of years, so 50 years. And that comes out to about $29,500. In 12, how much money are you completely wasting every time you skip a college class? Well, the information that you would need to calculate this exactly would be the tuition rate at your school, which varies depending on where you live, whether you're in district or out of district, and sometimes even with your degree program. You'd also need to know the number of class periods in a semester, and then the length of each class period, because if you had a class that met for 2 hours, you'd be wasting twice as much money. So let's make an estimate of $300 per credit hour. At most schools, each credit hour meets 1 hour a week for about 16 weeks, and then we'll assume this is a 1-hour class period. So that would mean that we're spending $300 for every 16 hours of instruction. So if I skip one of those, that's $300 divided by 16 hours. And so that comes out to $18.75 per hour of class. Question 1. According to a survey reported by the Nielsen Corporation, in the fourth quarter of 2014, the average American adult spent about 11 hours a day using electronic media, and the pie chart shows how those 11 hours are split up. Question 1. According to a survey reported by the Nielsen Corporation, in the fourth quarter of 2014, the average American adult spent about 11 hours a day using electronic media, and the pie chart shows how those 11 hours are split up. So this is out of 11 hours. So we're supposed to estimate how many hours are spent on each type of media. So looking at live TV, that's this largest portion here. So if the whole pie represents 11 hours, that is just a little bit less than half of that. Half would be 5.5 hours, so maybe that would be about 5 hours. The radio slice is this orange one. It's the next largest, and that looks like it's about a quarter of the pie. 11 is pretty close to 12, and a quarter of 12 would be 3. So we could call it roughly 3 hours. Then smartphone is the next largest from there, this gray slice, and that looks about half as big as the radio slice was. So if the radio slice was about 3 hours, smartphone would be about 1.5. And then they ask about DVD multimedia, which is the smallest slice, the purple one. And that one does not look like much at all. The smartphone slice we estimated at 1.5 hours. If you cut that into 3 pieces, they'd be 30 minutes a piece, and purple would still be smaller than that, so maybe about 15 minutes. Question 2. Here we're supposed to write the set of described numbers using the roster method. So in A, the number of people in a boat that can hold at most 7 people. We talked about in this lesson that at most means less than or equal. So we're looking at everything less than or equal to 7. The lowest number that we could have in a boat would be 0. So this set will start with 0. We can only have whole people. So 0, 1, 2, 3, up to 7. And that's all in curly braces. In B, the number of days you'll work out next week if you plan to work out at least twice. So at least is greater than or equal. So we're looking at greater than or equal to 2. That means the first number in our set is 2, and we'll count up from there, 3, 4, 5. The largest number of days you could work out in a week would be 7, so we'll go 6, 7, and then stop. And that's all in curly braces. Here we're estimating total costs by rounding each item to the nearest dollar. So in number 3, we have 4 boxes of mac and cheese at 89 cents a box. So we're going to do that as 4 boxes at $1 a piece. And so that's a total of $4 for the mac and cheese. Gallon of orange juice at $3.79. We'll round that up to $4. Loaf of bread for $1.79. We'll round that up to $2. And 2 pounds of ground turkey at $2.97 a pound. So 2 pounds at almost $3 a pound is $6. So we've got $4, $4, $2, and $6. And if we add all of that up, it comes out to about $16. In number 4, we have 2 pairs of jeans. One is $24.95, so we'll make that one about $25. And then the other one is $32.95, so we'll make that about $33. And then we have a 3-pack of socks that's $7.99, so we'll make that about $8. It's just one pack that happens to have 3 pairs of socks in it. And we have 3 workout shirts at $11.99 a piece. So that's 3 shirts at about $12 a piece. So that's going to be about $36. So we have $25, $33, $8, and $36. And if we add those up, it comes out to about $102. And in 5, we have 2 Xbox games, each of them regularly priced at $29.50 on sale for 50% off. So that's about $30 a piece on sale. 50% off cuts the price in half. So that's about $15 a piece, but there are 2 of them. So that brings us back up to about $30 for both. Then we have an iPhone case at $18.95, so we'll make that $19. And headphones at $22.49. That's just under 50 cents, so that'll round down to $22. And then we add all that up and we get about $71 total. Here we're looking at a quick way to estimate 20% for a tip at a restaurant. In part A, we've got $31.45. So the method is to first get 10% by moving the decimal point 1 to the left. So that would give us 3.145. Then it says to round that to the nearest dollar. So that's going to round to $3. That would be 10%. So for 20, we need to double that. So 2 times $3 gives us a tip of $6. In part B, we have $129.80. So I'll move that decimal point 1 to the left. That's going to give me 12.980. I'm going to round that to the nearest dollar, which would be $13. And then I'll double that. 2 times $13 gives me a $26 tip. Here we're using a bar graph. Here we're using a bar graph of violent crime rates for 5 different American cities in 2014. These are given as the number of violent crimes per 100,000 citizens. In number 7, we're going to estimate the number of violent crimes per 100,000 citizens in Detroit. So looking at the Detroit bar, it is right about at 2,000. And in 8, do you think your estimate may be too high or too low? It looked almost right on, but it's hard to tell because the lines aren't that fine. So the bar could end just a little bit before 2,000, so our estimate could be just a little bit too high. So then in number 9, let's write an inequality that says we may have overestimated and that rate may be just a little bit below 2,000. I'm going to assign a variable, so let's let V be the number of violent crimes per 100,000 citizens. And so we want to say that for Detroit, it might be 2,000, but it could be just a little less. So V is less than or equal to 2,000. In 10, describe the number of violent crimes per 100,000 citizens in Miami using either at least or at most. So looking at Miami, it looks just a little bit over 1,000. So the phrase that would say could be over would be at least. So we'll say that the number of violent crimes per 100,000 citizens in Miami is at least 1,000.